In this math talk, we're going to look at adding and subtracting rational numbers, or what we more popularly call fractions. And so we're going to begin with evaluate 2 over 8 plus 3 over 8, or 2/8 plus 3/8. Well, before I even get started on this, I want to draw a bit of a diagram to give you a visual. And so what I will use is a large yellow rectangle sliced into 8 equal regions. That's what we mean by eighths, and we discussed that before in our introduction to fractions. So if I want to consider taking 2/8 of that rectangle, well, my squares each represent an eighth. That means that I need to take 2 of them. And to that, I'm going to add from a second rectangle 3/8. Now, I am going to ask something unusual, something that I don't normally do. I'm going to bring in what is an incorrect answer because it's such a common mistake. And so I would ask you this: is it possible that the answer could be as simple as 5/16? In other words, what I've done is taken the two numerators, added them to become 5. In other words, the 2 plus the 3 to make 5, and the two denominators, the 8 plus the 8 to make 16. Could that actually be the answer? And I just want to show you how that is impossible, how that cannot be the answer. And let's take a look at another rectangle. So we consider our rectangle that was sliced into 8. I'm going to further slice that. So I actually have created 16 equal regions. So in other words, 16ths. And so now if I were to shade 5 of those regions, you would see this. And what you can see from that is that that amount, 5/16, is even smaller than the 3/8. So that can't be right. When I'm adding 2 over 8 to 3 over 8, I should be getting something greater than the 3 over 8. And this is actually less than the 3 over 8. And the comparison that I would make, or the reasoning would be, if I were to take 2 oranges and add 3 oranges, I think you would all agree that it doesn't make sense to write a final answer that is 5 watermelons. And that's kind of like saying 2/8 plus 3/8 is 5/16. 16ths are a different kind of slice altogether. And it's the eighths that you are counting. So you recognize that that can't possibly be the answer. And so we have to throw away that as a possible way to add fractions. As nice as that would be, we absolutely cannot just straight up add numerators and add denominators. But they're still fairly easy to add when the denominators are like. And so what I highlight to you is, if we take 2 oranges and add 3 oranges, we get 5 oranges. And by the same argument, if we take 2/8 and add 3/8, we must get 5/8. So that must be our answer. And so adding two fractions with like denominators is really straightforward. We say when adding or subtracting fractions with like denominators, do nothing to the denominators. So we did nothing to the 8 in each denominator. We kept our final answer having an 8 for a denominator. And then simply add or subtract, if it's a subtraction question, the numerators. There's nothing more to it than that. Let's try a couple. So looking at 4 over 11 plus 6 over 11. The denominators match, so we leave them alone. We're getting something over 11. Adding the 4 plus the 6, we get 10. Our final answer is 10 over 11, or 10/11. Let's try another. 17/24, subtract 2/24. We leave the denominator as it is, doing nothing to it. We just subtract the two numerators. 17 subtract 2 is 15. We always want to look at our answer when we're finished and say, is there any way to reduce the fraction, because it's important that we give answers in simplest form or lowest terms. When I look at the 15 and the 24, both of those numbers can be divided by 3, so I will do that. The 15 divided by 3 would be 5, and the 24 divided by 3 would be 8. So I get an answer of 5 over 8. Finally, 9 over 13 plus 10 over 13. When I add those, I leave the denominator alone because they're the same, and I add the numerators, and I get 19 over 13. Now I have a numerator larger than a denominator. I could leave my answer like that, but I do have the option to go to a mixed number. And so 13 fits into 19 once with 6 left over. So 1 and 6/13. That's all I want to talk about on this, because it's really a straightforward concept. So you're probably saying, what happens when the denominators aren't the same? And that's the subject of my next video. Thanks for watching.